Okay, welcome to the APAC webinar week, everyone. This is the second day of the APAC series, so if you haven't registered for any other slots and you're interested in topics, the URL is down the bottom of this slide. Just a reminder that once we've done this talk, there will be a survey at the end and there'll be a link down the bottom. Please complete the survey. It's very valuable to us. It gives us great feedback on what we can do next year for the webinar week and on the topics that you appreciated so that we can drill into those a bit more. This talk today is on top 5 ways to secure your business in the cloud. I'll be taking you through understanding the shared responsibility model that we operate here at AWS, building a secure virtual private cloud and how you can use some of our security tools such as security groups, NACLs, and internet gateways to connect into your hybrid data center, using AWS Identity and Access Management to secure your root accounts and other role access, protecting your content on AWS, so how you protect your databases, your block storage, and things like S3 with encryption, and building secure applications on AWS. Basically, how do you outscale attackers? How do you use our edge services to help you prepare for when things go bad? First of all, the shared responsibility model. You'll hear a lot about this from AWS. It is the way that we do security at AWS. If you look at this slide here, you'll actually see these are all the regulated and compliance programs that we currently run and the ones that we have been certified for. So you've got the ones here you'd be familiar with in APAC, such as ISO 9001 and 27001. We also have HIPAA if you're regulated by the health industry, FedRAMP for the US. Probably most importantly, we have FIPS cryptography, which is 140-2, which is for basically our physical data centers. And we also have PCI Level 1 service provider. So this allows you to run PCI compliant workloads in our environment. The one thing about AWS that's probably different to how security normally works is that we treat every single customer the same. So whether you're the US government, whether you're Netflix or you're a startup down the road, we give you exactly the same secure platform. We give you the same global service endpoints, and you get the same security team responding to issues that you would if you're a large corporate. What this means is that you don't have to focus on the things such as physical data center security, access security, all those kind of things, tagging employees and making sure they have good backgrounds. All of that kind of stuff is taken care of by us. What you need to worry about in AWS is the shared bit, which is that you are responsible for your content in the cloud and we are responsible for the security of the cloud. So what this means is that we will give you the tools to be able to secure your content, to be able to put in role-based authentication, to be able to patch your systems and configure your networks and firewalls the way that you want them so that you can secure the content. It is impossible for AWS to know what your content looks like. You are the ones who know whether it's important customer data or credit card information or it's just public stuff being served out of CMS. We cannot know that for you. So therefore, the way that we deal with security is to give you the tools to be able to itemize that stuff properly and then secure it in the way that you wish. Just to summarize on that, so security is our #1 priority. We have a full-time CISO. We have a security operations team that work 24/7 looking at security monitoring and like hardening our endpoints. Every single customer receives the same security. We do not have access to your data or guest OS. This is very important. We cannot see what you put on your servers. We can only see up to the hypervisor. Everything that is above that operating system, your data, we do not have access. What this also means is because we have such a varied compliance framework, you can use our certifications to reduce the scope of your own compliance audits. So if you need to get PCI certified or you need to get ISO certified, then you need to certify your content inside with your controls. You don't need to certify the data center and the other bits that we do for you. So that relieves you with much more time to be able to secure your own content on the cloud. So to help you work through how we have to give you the tools and how we actually provide you a secure environment, I'm going to step through the basics of a virtual private cloud, how we use things like security groups and knuckles to help you build up that overlay of your secure environment. So first off, we have a concept in AWS called Regions. Regions are where we have compute services available. So if you go and buy a computer in US West Northern California, it is located in that jurisdiction. Same with for APAC, we have Singapore and Sydney. If you buy compute in those, then that compute sits there. We do not move your data out of that region. You choose where your data sits. This is very important for privacy and for jurisdictional law. Each region is actually broken into availability zones. What this allows you to do is to build highly available applications across availability zones that sit in the same geographical region. The availability zones are connected with high bandwidth, low latency connections so that you can build active applications in those availability zones without having latency impact. The other important thing about availability zones is that they will always be made up of one or more data centers. They will always be on separate floodplains, separate power grids, just like your electricity provider wouldn't connect every major factory to the same grid. We do the same thing here. Everything is separate so that if you have a failure of one availability zone, it does not affect the other availability zone. We also have 52 edge locations around the world. These edge locations are where you can offload network traffic, for instance CDN. They're also where services like Route 53 sit. So you can use these to serve content as close to possible as your consumers to reduce latency and to take load off your application sitting in your source region. Just to recap on that, AWS is built a little bit differently to how you're using. We do not have DR. We have availability zones and we encourage you to build highly available systems. Masters in one availability zone, slaves in the other. We are 24/7 always on. So it's a little bit different to think about this stuff. We have multiple redundant Tier 1 ISP service providers. All the basics for you to be able to build an application that has very quick failover with minimal downtime are there. It comes down to how you've actually architected your application. So to kick off, now we have a concept of regions. Let's look at availability zones. So this is the standard AWS diagram that you would have seen around the internet if you've looked at any kind of our architecture pictures. We basically draw it like this. You have availability zone A, availability zone B. They are separated by the same things I said before, power grid, data plane, flood, all that kind of stuff, different electricity. When you build a VPC, which is Amazon's virtual private cloud, it actually gets spread across both of those availability zones. So by default, you get an active VPC. You can choose to deploy your instances from AWS in availability zone A or availability zone B. And you will basically build an active application out of that. The way that you set up a VPC is you need to choose a Sidle block. Sidle blocks are something that came around after we got rid of Class A, B, etc. networks on the internet. You choose a Sidle block for your virtual private cloud. It is your own address range. It does not interact with us. It is something that you can use to extend your data center if you want to. The maximum that we allow you to choose is a -16, which is 65,000 plus IPs. We probably recommend that you don't choose a -16 because if you do something in the future like use a direct connect and you need to connect back to on-premise, then you'll most likely have overlapping IP ranges where you'll wipe out 65,000 that you can't use, because if you're advertising those IP ranges back into your own network, they can't clash with any of the ranges that you currently have advertised in your own localized data center network. For now, let's concentrate on a single availability zone to make it easier for you to understand the security concepts. They apply to both availability zones, and we'll get to that a bit later on, but right now I want to drill down into the actual basics about how you can secure your workloads inside AWS. The first thing to do after we choose, so we've got a -16 here, is to actually break our network down into subnets. So at the top, we basically have a DMZ type subnet. Second layer, we have a web. So they're all -24s, and then we have some other like service subnets that we can choose to put things into. Once we've broken down our networks, we can then move into putting our instances inside the VPC. As you'll see here, as I was saying, we have web, we have database, we have app, and we have a services that has jump, log, and other types of solutions in it. When you launch an instance, you choose what security zone it goes into. If you've designated 10.0.2 as your web, then you choose that subnet to launch that instance in. You choose where each of these applications go. We don't force on you, you have to put everything in a DMZ, or you have to put everything in a backend tier. You get to choose where that is and what security is applicable for that layer. If we add security groups into the mix, you'll see that we have one here called web servers cannot connect to app servers on port 80. So what this is actually doing, you'll see the web and the app both have this security group around. So web can now connect to the app server down in the 10.04 network on port 8080. No other connections are currently available in here because nothing else has security groups that allow it. We can add a second security group. Each instance can have up to 5, which will allow outbound connections to the log server. This means that your web, app, and DB can now push traffic to the log server. As an important thing about security groups is that they're actually stateful. So if you allow inbound port 80 to the web server, it will always be able to do return packet task for 80 for that connection. So that's one thing to keep in mind. If you allow inbound rules, the outbound will always be allowed because they are stateful. We can take this up a notch and do some management. So if we put a third security group around these instances, which has an allow SSH and allow ICMP from the jump host, this allows the people who are moving into your jump box either through on-premise or from the internet and SSHing around the place or RDPing around the place to actually ping all of your instances to check their health. It also allows them to SSH in. Now, security groups operate at the instance level. This is very important because it's very different to how you would traditionally build a network. If you had 2 web servers sitting in 10.0.2, in a traditional network, they will be able to talk to each other on whatever port they like because they are sitting next to each other in the subnet. They do not have to traverse a firewall. In AWS, we actually give you horizontal protection as well as vertical protection in your security groups. You cannot talk to Web 2 if Web 2 does not have a security group permitting Web 1 to talk to it. There's 50 rules per security group, and you can put 5 security groups per instance. So you can have up to 250 rules per instance, which should be enough for most people's needs. There's another thing about VPC that's slightly different. There is actually a built-in router in a VPC. This will be the .1 address of your Sidle block. So in this case, it'll be 10.0.0.1. This router will always allow any of the subnets to route to each other. This means that currently your DMZ can talk straight to your database, or your web can talk straight to your database without going through app. Now this is not ideal behavior when you're trying to secure your VPC. So we give you another tool, which are called Network Access Control Lists, or NACLs for short. NACLs allow you to, at the subnet level, apply rules which are deny and allow rules to each subnet, saying, for instance, that web will not be able to talk directly to the database, whereas app will be able to talk directly to the database, and DMZ doesn't get to talk anywhere in this model. So this allows you to further secure things not just at the instance level, but at the subnet level, and block traffic that you don't want happening, such as web to DB direct. NACLs are optional. We have customers who don't use NACLs and they only use security groups. It depends on how you need to break up your boundaries. If you think that security groups with their statefulness are enough for you to be able to split up your applications and your things, or if you have a new age application where basically everything is a microservices container and it doesn't really matter if they talk across because they're always going to go out to the internet edge and talk HTTP, you can choose to have an entirely flat network and not use things like NACLs. You just use instance security groups. It's up to you whether you apply these controls or not. It does give you an extra control point. For instance, if you're in the DMZ or in the web and you put if you have a security group that basically says only allow port 80, but a developer or someone comes along and launches an instance into that 10.0.2 and it wants to allow port 22 from the internet, you can have NACLs on that subnet which strictly prohibit so that only port 80 can come in. NACLs are not stateful, so you would need to allow inbound traffic and outbound traffic for the ports that you do want, for instance 80 from the load balancer. This gives you an extra part of protection because you can break down who can control NACLs. So you could say the network team is allowed to administer NACLs, but the developer teams are only allowed to access security groups. This means that your NACL will basically be a catch-all in case someone does accidentally launch an instance where they don't have the right security group on there so that you block all that incoming traffic from the internet. On top of this, we have elastic load balancers. So elastic load balancers, if you used a traditional IT, would look at something like an F5 or an F5 LTM or an Imperva or those kind of things. ARILBs actually span availability zones. This one's only drawn here in the single availability zone. It lets you load balance between your application servers and your web servers. Load balancers also get their own security group. So you can put a listener on one of our elastic load balancers that says serve traffic only on 443, and when it terminates the 443 with SSL, then serve that to port 80 on the web servers. You can then put that same security group around the web servers which say only allow traffic from 10.0.1 into the web servers on port 80. This means that you can't directly access the web servers from the internet this way, so you get one extra layer of protection. The load balancers will only listen on ports that they have listeners. They will drop all other traffic. So any other traffic destined for your VPC from the internet that is hitting that load balancer will be dropped. One more important thing is around auto-scaling. So if you put your web servers in an auto-scaling group, which is a much documented AWS feature, this would allow you to elastically scale based on load. You can set triggers such as, if I hit 80% CPU, spin up another web server so that I can handle this load better. Elastic load balancers, when they are attached to an auto-scale group, know about this behavior. They will register and deregister instances that are coming into that pool automatically from no work from you. So this is a good way to be able to ramp up and ramp down without having to do any manual intervention. Security groups always scale. As those instances are added into that auto-scale group, they will automatically be assigned that green security group. So you don't have to worry about applying security after the fact if you're auto-scaling. Now the bit we haven't really talked about is connecting to the internet. By default, your VPC is completely isolated from the internet. So your instances can't talk to the internet, and no one can talk to your instances inside your VPC. Now most people who are going to build applications that do need web access are going to want the internet at some point. So we have a thing called an internet gateway. So if we attach this to the picture we were just looking at, we can see the internet gateway actually attaches to the top of a VPC. An internet gateway will allow you to will allow people to come into your VPC, and it will also allow you to give your instances addresses to go out to the internet. By default though, only subnets that you allow into the routing table to actually access the internet gateway will be able to get to the gateway. So this is the further bit where you can basically say this is a public subnet and I want it to go to the internet, and it's now going to get public IPs that Amazon manages. You can also specify elastic IPs. If you need to stick an IP to a particular number so that you can use it, for instance, to do SSHing, or you need to put it into your corporate firewall, you can use an elastic IP with something launched in a public subnet so that you can do this. What it also means is that all of your other subnets at that point become private, because now they will have no route to the internet and they'll need some other access to go through to the internet. This becomes an issue if you have a Windows server or a Linux server and you need to patch it, or you need to do a yum update, or you need to get some other kind of content on there. At the moment in your VPC, you have no connectivity back to your data center, and you have no connectivity out for those private subnets. So we also provide NAT instances. These are AWS AMIs that you can spin up inside your VPC in a public subnet, and they will allow your instances to connect out to the internet without getting a return address, so that they can go out and do things like yum update or pick up a SUS update or anything like that without exposing them to the internet. They are protected by the NAT server. This is also the way that you will access regional services from Amazon. So regional services are things that sit outside your VPC. Good examples of those are S3, Dynamo, SQS, any of those kind of things that aren't specifically built inside your VPC. So if you needed to, for instance, upload a backup or push some data to S3 or read some data, you would need a NAT instance for those private instances to be able to connect to that, because the S3 endpoint is a public endpoint. So the next bit that we have in the puzzle is connecting back into your premise. Just about everyone who uses AWS is going to have some kind of system internally, some kind of data center that they want to connect to, or even an office where they want to VPN into the AWS ecosystem. So we do this by providing a virtual private gateway. So we had Internet Gateway, this is Virtual Private Gateway. The idea of the Virtual Private Gateway is it would terminate private connections for you. So whether that's VPN, Direct Connect, or any other way that you want to actually connect in. So this basically acts as a second edge. So you can, for instance, connect your virtual private gateway to your premise over IPsec tunnels and VPNs. So this allows you to securely connect back to your premise, connect into your VPC over the virtual private gateway, and move traffic between them without touching the public internet. This is a very common pattern that we have a lot of customers doing. Most people would like secure their things with either SSL or IPsec VPN tunnels into their VPC if they're connecting back home. You might have a heavy database that you haven't migrated back to Amazon yet, or you might have some other thing like a federated AD service that you want to connect back to so that you can manage users inside your virtual private cloud. So customer gateways and virtual private gateways allow you to do this. We also have Direct Connect. Direct Connect is our direct fiber connection. It comes in 1 gig or 10 gig ports natively. There's also providers in APAC who will cut this down to you so you can buy it in 100 meg or 10 meg or other chunks. I think 100 meg is actually the minimum. So what Direct Connect is it's a dedicated link to us that doesn't traverse the public internet. It's basically a peering location, and it'll give you a low latency, high bandwidth connection into AWS. This is useful if you're doing things like backups to S3. If you're doing multiple gigs or hundreds of gigs a day, you're not going to want to push that out your premise internet and just basically crush your bandwidth. Direct Connect gives you the option to push the traffic up through into your VPC over that link. The other important thing about Direct Connect is it's much cheaper. When we charge you for data, we charge you for outbound data out of the VPC. If you're pushing a whole bunch of backups, or if you're pushing some kind of metrics or app data back into your premise through the VPC, if you do it through Direct Connect, you're basically saving 10 to 11 cents depending on your region between the public internet and the Direct Connect. You can also create VPNs over the Direct Connect. I advise you to basically look at the traffic if you're going to use a Direct Connect and decide whether, because it's a private link, whether you need to encrypt it or not. If you've got highly sensitive information such as credit cards or something going over there, you might have to create a VPN just to get compliance over the line. So we allow, it's up to you. We don't force you to do it, but we do allow you to do it if you need that level of protection. You can also route your internet back through your own on-premise gateway. So we allow you to do this. So you could, for instance, have no internet gateway in your VPC, and every time one of your servers wanted to serve something out, you could push it back through the direct connect, which is very low latency because it's a direct fiber connection, through your on-premise and out to the internet. This means that you could serve your web straight out of your own internet premise gateway, but to host it internally. We see this pattern more often for things such as SAT or big enterprise applications such as SharePoint, where you basically just want to build a virtual private cloud and keep it away from the internet. So this is a very common hybrid architecture. Remember, everything in Amazon is not public unless you make it public. So by default, you are private unless you attach one of those internet gateways where you can then get to the internet. You can do both. So you can have an internet gateway where you want to push out to things like Amazon S3 and Dynamo. You can have your NAT servers, those kind of things, and you can also connect back into on-premise. We leave it very configurable. You need to decide what's the risk profile of your content, how you want to connect to it, all those kind of things. So we give you the option, and you can choose any way that you'd like to mutate that into the virtual private gateway or the internet gateway. And as I was just saying, you basically have full control. We don't really stop you from pushing traffic back and forth over which way, routing some things through the internet, routing some things back through your direct connect. It's all BGP routing for the direct connect, so you can choose which parts to push back down there based on your customer premise. We have people who have things like their web servers in auto-scaling inside their VPCs, and then they have the database on-premise through the direct connect, and they connect that way. We have other people who have whole applications sitting in Amazon going out the internet gateway, but they choose to use direct connect for things such as management. So you have to be on-premise to be able to manage AWS. So just to summarize on this, so VPCs are private until you decide to make it public. Security groups block horizontal as well as vertical. This is very important for people like architects who are planning about how they're going to do perimeter security. You cannot talk to the web server next to you unless it has the same security group or it's part of the same application with that security group. We do block horizontal, so you can create much flatter networks. You can use your own internet in your DC. So if you feel like you've got perimeter protection or some other reason that you need to traverse back into your DC and push out to the internet, you can do that. We give you the tools to be able to do that. Don't expose your instances to the internet. Although you can attach elastic IPs, using NATs and ELBs, there is generally no reason to put web servers out onto the internet. Protect them with the ELBs and the NAT. You do not need to give them static IP addresses, generally. And creating hybrid architectures. So you can do that with VPNs and with Direct Connect. VPNs can also act as a failover for Direct Connect. So if you have a Direct Connect, say for Equinix here in Sydney, you can also have a VPN endpoint that you can fail over to if the Direct Connect goes down. So if you have enterprise critical workloads in AWS, you can use the VPN as a backup for the Direct Connect. You can also have two Direct Connects. The choice is yours. Next, after sort of a basics about how to build virtual private clouds, what security groups are, I want to go through securing your account. This is a very important part of the AWS ecosystem. Your account allows you to do everything, especially the root account. You can delete content on there, you can create servers, you can run up huge bills. This is probably the most important part of making sure that you have a robust, secure AWS engagement. First off, MultiFactor Authentication. We support Gemalto tokens and we also support soft tokens. If you have root account credentials that are currently not got MFA enabled, please enable them. This will give you two-factor authentication to secure your root account so that people can't come in and do malicious things into your account. You don't need to use the root account as well. So if you're a multi-account enterprise which a lot of people are, or even if you just have a single account, try not to put critical workloads and critical infrastructure inside the thing and manage it with your root account. Create another IAM user with a different role that can't do really damaging things. Also, if you do have a root account and multiple sub-accounts, which we support, try not to put anything in your root account at all. So have no instances, no services actually in that root account. What this means is that the people who are using the other accounts, so your developers, your projects, your business units who you have signed these credentials out to use in the sub-accounts, there is no reason for them to log into the root account. The only power that a root account has over a sub-account is that it can delete accounts. There is no reason on a day-to-day basis operations or your development team should be logging into that root account. So keep it multi-factored, put it in a safe if you do have a root account thing where you don't need to access it a lot. On the iPhone and on the Android, we offer the Google Authenticator for the actual soft token, and there are a few other vendors as well. There is a compliance spec which you can go and look up, which talks about the actual cryptography that we use for that two-way authentication. Second, on every account that you have in AWS, enable CloudTrail. CloudTrail is our API auditing service. It will log every time someone accesses an API, and this is even from the console, which does access the API. So accesses the API, what their IP is, what their user was, and what was the actual call. So for instance, we're talking about not attaching elastic IPs before. You could actually set up a CloudTrail alert through CloudWatch, which would basically alert you if anyone attached an EIP to a server sitting in one of the DMZ subnets. So you know instantly, well, it's now out open to the world, and if that's a Windows server with no antivirus protection, it's going to get compromised very quickly. You can use CloudTrail to find out these things, to go through these logs and to raise alerts on these type of actions. Roles. Roles are very important. Basically, you should not be creating IAM users if you have federated access, and you should not be putting credentials on your AMIs. You can use roles now to allow your resources to contact other resources. If you put a role into an EC2 server that says you can now read from a particular S3 bucket, you do not need to load credentials onto that AMI. The same for users. If you create users, put them in roles. That will give them certain access to do certain things. It will all be logged through CloudTrail, and you have a nice audit trail of don't give people admin accounts or the root credentials. And lastly, federate users with on-premise. So we now offer SAML 2.0 federation. You can federate with Active Directory that's back in your data center. So this would be, if we have that hybrid cloud model with Direct Connect, you can put a read replica of AD out inside your VPC, and you can use that to administer users, so you're not administering them in two places. Just want to go a bit deeper into roles. So I have a saying here, which is you get to choose who can do what in your AWS environment and from where. That's basically the tagline of roles, and I've just got a few examples here to sort of demonstrate that a bit more. So the one I was just going through here, a web server can access S3 to read static images from your private subnet. So if you actually give that role to that particular web server when it's created, it will forever be able to read that S3 bucket. CloudTrail can log all interactions with your AWS APIs for your account. So this is a role where you're giving our service access to something in your account. So you can say CloudTrail can now write logs to an S3 bucket for all of the people who access my APIs. So roles are not just for people or machines, they're also for our services. And then lastly, a user one. So Simon can create snapshots for RDS, but he does not have the permissions in this role to be able to restore data from them. So he can do an operational, if you're in an outsourced environment or you have a separate ops team, you can allow them create backups but not do restores unless the DB's team is there to overwatch. So roles are very powerful. Take some time designing them, get them right, and then you should never have to put credentials into your applications or into your AMIs again. Just delve into federation a little bit more. So the idea with federation is that you can manage all your users from one place with single sign-on. So we do this by allowing you to assign roles and then having people in those roles assigned to your federated user access. So Active Directory is supported, the directory service that Amazon has supported, anything that SAML 2.0 is compliant is supported. We do have customers who spin up their own LDAPs inside AWS because they do not have, say, a hybrid data center model where they have another data center, and then they use LDAP to manage their users, and they federate it back through with SAML. So it's just up to you how you want to actually do that, but try not to manage users in two places. If you're in a financial institution or somewhere that's got rigorous user control management, try and get some kind of read replica or something else pushed up into Amazon over a VPN or a direct connect so that you can manage users in one place. This will save you a lot of time and pain. If you have people who are leaving and you have to remove them from on-premise and from AWS and you haven't updated that process to do that, you're going to have users there who have access to your systems. Whereas if you have single sign-on, that one process will take care of that kind of stuff and your AWS user management will be much easier. So CloudTrail. So CloudTrail will record access to everything, turn it on in every account that you have. We log the IPs and the users and everything else. It's probably the most important service for security and audit that we've released recently. Even if you don't plan on using it for anything, turn it on. It will just create a whole bunch of logs about who accessed what that might be useful later on. We also released a feature last year which is CloudTrail logs. So you can now look up your CloudTrail logs inside the console. You can also integrate them with CloudWatch and set alarms off in CloudWatch. So you can use these CloudTrail logs for security analysis, for recording changes, for compliance, so you can understand the history of changes because you can see every call that everyone's made to change a security group or made to change anything inside a VPC. And also troubleshooting. If you look at if you have CloudTrail logs set up and you look at the last entry in the log and your web servers are no longer working and you look there and you can see actually someone's just removed port 80 from my web server, now I know why it's not working. So they can help in troubleshooting as well. It's a very important feature and it should be enabled. With CloudWatch logs monitoring, it's not just about endpoints. So with your CloudWatch logs, we will put an agent onto your EC2. That agent can be configured to monitor EC2 health stats such as CPU, but it can also be monitored for things like Nginx or Apache logs or any custom log that you basically build a config file for so that we can process those logs and push them to S3. CloudWatch logs being the primary metrics aggregator in AWS also has alarming. So you can alarm on things like 404 errors that get to a certain percentage in, say, 5 minutes on Nginx. You can do very powerful things with shifting time, creating alarms from monitoring, and these are going to be all automated. They will give you an SNS message, and they will basically, you can email that. If you're in America, you can SMS it, or you can do things like Apple Push or Android Push. So you can basically give yourself real-time alerting of issues like this going on. AWS Config was a service that we announced at reInvent last year. It will give you a visual history of things that have changed inside your VPC. So if you look at this screenshot on the screen, you can see 7th of November, there were 6 changes to this particular VPC. So every time that you make a change, it will give you a timeline history of what changed, who did it, and what IP did they come from. So you can do something such as have a security group in config, then you can see, okay, it's changed 7 times, and I noticed this developer changed it to this on this date. So you can have a snapshot with a complete history of how that changed over time. AWS Config is also integrated with ServiceNow. So if you use ServiceNow for CMDB management, then there is an API that ServiceNow has developed which will plug into AWS Config, and it will automatically pull down that snapshot history about when that particular resource actually changed. This is the list of integrations that AWS Config currently has. So any of these will spit out a customer change history record. You can also use the SDKs and the CLI to use AWS Config. So you can write scripts to take snapshots. So you can take a snapshot every 10 minutes of here's what my VPC, EC2, Elastic IPs look like, and you can create another one in 10 minutes and basically diff it. So you can write programs around AWS Config to understand what's changed in your network, or to raise alerts, or to do those other kind of things. This will give you much more granular detail about what actually changed inside of VPC, as opposed to CloudTrail, which is showing you that someone accessed an API to change something. This will show you the detail in what actually changed in that VPC. Okay, so protecting your content on AWS. So this is around encryption, what security layers you will use, and what tools we have to help you be able to secure your data in transit, at rest, and in use. So the ways that you can store data on Amazon are basically broken down into these 4 ways here. You've got the simple storage service, S3, which has an API endpoint. It's an object store for storing data. We have Redshift, which is our data warehousing engine for large data sets. And then we have RDS, which is managed relational databases. So we currently support Oracle, Postgres, MySQL, and Microsoft SQL Server. And we have EBS, which is the Elastic Block Store. So this is the EBS volumes that you attach to an EC2 instance when you launch them. You'll notice that there's no EC2 normal storage on here. That's actually ephemeral storage, which is our boot volume. So if you restart that server, or you turn that server off and you're using an ephemeral disk, it will be wiped. It is not continuous storage. That's why you attach things like Elastic Block Store for this. The other service that we announced last year, which is important for all of this, is the key management service. Now, the key management service was actually in use a little bit before it got released, because if you've seen the EBS announcements about doing server-side encryption on EBS by ticking a box, it was actually the key management service in the background. So the key management service provides AES 256 encryption for any data that you decide that KMS can manage with the keys. We allow you to do things like rotate keys, disable keys, create client keys from master. It's integrated with our SDKs. It's integrated with the console. You can basically do full customer key management with the key management service. This takes a lot of headache away from doing things like writing custom libraries to do crypto on top of things. With a simple checkbox, you can encrypt, S3, EBS, Redshift, and RDS. So dive more into S3 security features. So first off, S3 is managed by AAM. So access is managed. It has bucket policies. You can give exactly what we're talking about before. Who, so you get user A or service A who can access this bucket, and they can access it for reads. You can also lock it down to IP. You can say this user can only read it if they come from this source IP. It also has versioning. So you can turn versioning on inside these buckets, and every time that someone updates a file, we will keep an older version of it for you, so you can get history revision and go backwards. We also offer multi-factor for delete. So you can actually get a whole nother hardware token or a soft token on your S3 bucket, and you can say if anyone wants to delete anything out of this bucket or the bucket itself, we'll give you multi-factor authentication. So if you're a business that's in compliance and you've got 7-year retention, or you've a financial institution who's decided to keep your history for longer than that, you can put MFA on here and basically prevent people from deleting. You could even get a Genolto hardware token if you think you're never going to delete the data and your business is always going to want it, but you can connect it up and then you can smash it with a hammer and no one will be able to delete that data, so you'll be keeping it forever on S3. You probably don't need to go to those extremes, but we give you the option if you want to. So S3 has server-side encryption, which is using KMS. So you can create keys for your bucket, encrypt that data, and we will manage the keys for you. You can also use client-side encryption where you bring your own keys. So you can encrypt before sending it to S3. You can use the SDKs that we have to basically encrypt that data and then upload it. At that point, we don't have any keys or any access to your content anyway, so basically you've got fully secure content. Redshift, so this is our data warehousing product. It offers one-click full disk encryption. So it also, it has two methods for encryption. You can use an AWS Cloud HSM, which is in the background is a SafeNet Luna device. So it's a FIPS2 certified, tamper-resistant for storing your things. It basically generates a master key. It's a single tenant device for your customer, and then it generates client keys. You can never export the master key out of one of those devices. So you can use Cloud HSM or AWS Key Management. They're both natively integrated into Redshift. So if you're doing data warehousing where you want to have the last 4 digits of credit cards, or privacy law for Australia where you have full date of birth, name and address, and you want to do encryption, we make it very simple for you. The only caveat is if you have a Redshift cluster already, you can't encrypt, you can't change the encryption. So you need to create a new cluster that's encrypted and migrate the data into it. You can also, all of your backups that go to S3, so Redshift natively backs up to S3, they will be encrypted the same way that you put the data into Redshift. So when they land on S3, they'll be encrypted with the same method that you use. Redshift also supports HTTPS and SSL access. So you can, for your data when it loads into Redshift, which has to go through S3, you can do HTTPS SSL encryption to S3. You can then use S3 client side to encrypt the data. You can then push that to Redshift, and then it will upload that data by decrypting it. So you can do a full end-to-end workload for moving your data into the data warehouse. RDS is our managed database service. We have different options based on the database that you're actually using. So for instance, at the moment we support native RDS encryption for SQL Server and Oracle. We do not support KMS for those two engines at the moment. We do support KMS encryption for MySQL and Postgres. So you can do the same, tick a box, stand up an encrypted cluster, migrate your data into it, and KMS will manage the keys. Encrypting EBS. So EBS was the first service to use key management service. You can, when you create an EBS volume, either through the CLI or through the console, you can tick a box and basically say encrypt this data. It will be AES 256 encrypted. The keys will be managed by KMS. You can create keys ahead of time if you want to use the same keys for EBS volumes, say attached to some kind of app server where you want to keep state, or you can have it generate on the fly where you'll get a different key per server. On top of that, you can also use things like BitLocker, Linux Lux, we've got SafeNet products, Trend. So you can actually use cloud vendor software on top of the EC2 instance itself to actually encrypt that data. What I'll say about that is if you are going to go down that path, then make sure you're ready for doing things like rotating keys, keeping the master key secure, making sure that you have someone who actually knows how to encrypt and decrypt that thing if you need to do restores, all that kind of stuff, so that you can prevent loss in the future, that you somehow lose the key was sitting on someone's PC that is no longer with us, all that kind of stuff. So really think carefully about how you're going to manage keys if you start encrypting sensitive data, and it's also the master source of that data. So I was touched before on Cloud HSM. So Cloud HSM is a managed single tenant SafeNet Luna device that we provide. If you have currently used HSMs on-premise, there is Cloud HSM Sync, and you will be able to sync your Cloud HSMs with your on-premise HSMs. So this allows you to retain full control over those keys that come out of your, so you'll basically only have the client in the Cloud HSM. So we will never see your private keys if you do this model. Have it in a HA pair. You don't want your Cloud HSM failing and taking out your critical services and not being able to decrypt data. And also, most likely put that over a direct connect. You're not going to want that connection to fail if you're doing sensitive workloads across there. Okay, the fun part. So, at the start we talked about how you can build virtual private clouds, how you can secure them down. The value really in AWS is how you can build secure applications, how you can manage your content, and how when you do have threats that present, how you can manage your way out of those. So one of the things that's very important to understand about AWS is there is no layer 2 network. You cannot poison, you cannot get layer 2 access. You cannot plug in a spam point and inspect traffic. Just about every attack that people see these days is layer 7. It's going to be some kind of specific attack against your application. Maybe it's WP admin because you're using WordPress, or maybe it's -CGI bin because you're still using PHP. Whatever it is, it's not going to be targeted at layer 2. And there is no layer 2 attacks possible in AWS because your VPC network is one level higher than that. So there's a couple of things that you can do. How do you protect your applications that are running on AWS? You can do things like put things in a DMZ. I guess the issue with that is that then what you're saying is I'm happy for just about anything in that DMZ to be compromised, which is probably not a good security approach. If you think about like layer 7 devices that you can go and buy out in the market, they do things like WAF. They do things like return proxy path, where if they see something that looks like a credit card, they'll actually block that out in the return packets. So you need something that's a layer 7 deep inspection to be able to protect you against those kind of threats. And so what I'm going to take you through now is a way that you could build out that kind of layer for protecting your apps in the cloud with AWS. So first off, if we go back to the picture that we had before, this is a multi-AZ reference architecture for building a web application firewall. So this auto-scaling group in the middle, in the grey and the green, is basically a WAF layer. So it's what we call a WAF sandwich because it's sandwiched between two elastic load balancers. So this would allow you for all incoming traffic to basically push it through a WAF layer, do layer 7 inspection, check whether it's a malicious SQL injection or some other type of attack before passing it on to your web application servers. They're in auto-scale groups so that if you get high traffic or you get some kind of volumetric attack, they can scale out and help protect you and not become a single point of failure. That's also why they're wedged between the load balancers. One of the other common practices when building things like a WAF sandwich is using VPC peering. So with the advent of VPC peering in our network, you can now have multiple VPCs that are peered together. So those networks inside each VPC can talk to other networks which you can lock down with knuckles. What this means is you can have a VPC which basically houses that WAF architecture we were looking at in the last slide, and have an internet gateway attached to that, and it is the inbound route for all of your traffic. You can then, once it has looked at that traffic, peer that down into your web application layer or into another layer. So you can basically have fully segregated web apps with no internet gateway and have the WAF servers peering into them. This is the same for outbound traffic. If you want to have a proxy traffic like Squid or any other kind of thing so that you can control what can get out and when, you can have a proxy VPC which also has an internet gateway where everything uses the peering to basically target up into that proxy service. So with this you have fine-grained control of inbound and outbound traffic. So given what we just talked through with WAF and those kind of things, there's some more important things to realize, I guess, about how attacks happen on the internet. So if you're going to get denial of service attacks, they're going to be huge volumetric non-layer 7 attacks generally. Now you don't want, if you're paying for on-demand services in an auto-scale group, you don't want to have to auto-scale your server fleet out to 200 servers to mitigate that type of traffic. So there are ways that we can help you build architectures which will help you protect against these attacks. So here's your player one. This is your VPC. So we've got auto scaling, like I said. So you can set the maximum number on your auto scale group to 200, and you can try and outscale. So you've got your VPC, you have AWS scale and bandwidth, so you're using our internet. If your application is stateless, your auto scale is basically limited to the what we put on the auto scale group. You know, database sharding, those kind of things, so that you can basically use your own compute to try and outscale the attack. But once an attack gets big enough, that's going to be pretty hard. If you've ever worked in traditional data centers where you've got fixed links, you might have 1 gig to the internet or multiple 10 gigs or anything like that. Eventually you'll get an attack that just consumes all that bandwidth, crushes your routers and your firewalls, takes all of your thread pools on your web servers in Apache or whatnot, and basically just takes you down. So you can also bring AWS to the party. So we offer edge services which will help you scale and basically outscale your attackers in these events. So I'm going to talk through 3 services: CloudFront, S3, and Route 53. So AWS. So we have 52 CloudFront edge locations around the world and growing all the time. If you proxy your content through CloudFront, and you can proxy it through, we allow you to set a TTL of 0. It's probably the most important thing about CloudFront. You can proxy all traffic, whether it's dynamic or static, through CloudFront endpoints. This means that it's going to come through our edge. This means by default that we will do things like drop bad packets. You'll be using our edge internet instead of your VPC internet that you're paying for. All those kind of things. Route 53, our DNS service, it has 100% uptime SLA. If someone's trying to DNS poison you or do some kind of attack that actually attacks a DNS service, if you're using Route 53 and you're using our name service, they're actually attacking our service, not yours. It is our problem to outscale it. We have 24/7 SecOps teams responding to every attack that happens at AWS. We have a whole team of people sitting there. We don't need to ring someone on call and say, you know, log on and see if something's gone wrong. We are watching that stuff. Like I said before, we drop malform requests. If you've got some kind of bad thing like an NTP reflection attack or just bad like DNS packets or something, all of that is dropped at the edge. It will not get to your VPC. So let us drop that traffic for you. So I'm going to take you through how that actually works in practice and what it would look like from an architecture point of view. So first off, you've got your customers, you've got your sort of design that we're talking about here, you've got your internet gateway, you've got your ELBs, and you've got instances sitting in autoscale groups. So first off, one of the things that you can do to offload load from your actual servers is put them in S3. So S3 at any given time is processing more than 1 million requests a second. It is built for scale. And so if you have static images or things that don't update very often, or you want to push stuff that's in your CMS that hasn't been requested for years, you can push that stuff into S3. S3 offers basically turning a bucket into a web service host. And you can also put your own custom DNS on top of that. So if you move your static content to there, every request for that image, your favorite icon, the things that don't change very often are going to hit S3 and not your VPC, which means you don't have to worry about anything that basically targets that static image. Secondly, you can put all of your static content through CloudFront. So as I was saying before, CloudFront will have 52 edge locations. It will choose the closest path to your customer and serve that traffic back. It will not come, apart from when you have expiry on your HTTP cache headers, it's not going to come back to origin. So it's going to greatly reduce the amount of traffic you have. If your origin happens to be an S3 bucket, it's not going to hit your VPC at all. If you have some script that every 10 minutes pushes images up to that S3 bucket, it's going to completely bypass your VPC. Any volumetric attack that comes through there is basically hitting CloudFront and then going to S3 and is not affecting your service. So now that you've got edge locations set up and you've got Amazon S3 serving, those edge locations are distributed all around the globe, and they're choosing where your customers are coming from. You might have legitimate customers coming from Singapore, but you have bad traffic, say, coming from another part of the world. Those edge locations will be serving that content close. So as long as they can do origin requests or Amazon S3 requests, they can keep serving that content while the other edge locations deal with an attack. CloudFront has built-in protection to drop bad packets. So if you get any kind of malform request coming, it will get dropped at CloudFront. It will not come back to your VPC. You don't have to worry about protecting against that kind of stuff if you have CloudFront. If you're worried about using CDNs in front of your content because it's dynamic and it changes all the time, then you can set a TTL of 0, which just means that it will proxy through CloudFront and still just get served straight from your origin all the time, but you will get the added protection of the having the internet edge and also dropping the bad requests. To add to this, if you use Route 53 for your DNS requests, Route 53 has a 100% SLA. If you're using our name servers, every DNS request is going to hit our edge service. It's not going to come back to some DNS in your premise or in your VPC. So our entire job is to basically provide you with large-scale endpoints 24/7. Our job is to secure those endpoints. Our job is to keep malicious traffic out of those endpoints. We have 24/7 security SecOps teams looking at this stuff. We do root cause analysis on any incidents that we have. We then go and look at those services and fix them for next time. Our job is security, and we will secure those endpoints. So if you use those endpoints, you're basically getting a whole other team, a whole dedicated SecOps team looking after your infrastructure without you having to serve a single request. So if you have CloudFront in place, Route 53 in place, Amazon S3 in place, you have autoscale, WAFs, all that stuff we talked about before, you will be able to outscale your attacker. You can scale your autoscale groups up to hundreds. They are not going to outscale S3 or CloudFront. So you can use these as added layers of protection. If they do come through because you're proxying content and hitting you, you're going to have such a diminished load because the edge locations are actually pushing that content through. Amazon S3 is pushing out your static content. You're going to have a much better chance of surviving and not giving degraded service to your customers. So at the end of the day, it's actually about whether your web page slows down or someone can't get their financial transaction through. These are the things that we're trying to help you protect against. You can't give a 100% guarantee that you'll never get affected, but these edge services can help you get there. And all you have to do is turn those services on and place them in front. You don't need to do any mass configuration. You don't need to go out and buy 10 gig links to actually help this stuff. So we are trying to help you protect this stuff at the edge, so it doesn't come back to your VPC and it doesn't drown out your application that you may be making money from. So Route 53, so on our global DNS service, you will also be able to do load balance across regions. So if you have a VPC in Sydney and one in Dublin, Route 53 will actually balance that into the closest region. So you can run apps in all 9 of our public regions and have Route 53 distribute that load between the apps. So this gives you a huge advantage if you're a multinational company where you need to run the same kind of app around the place, because you'll be distributing it off into its own localized region. It has health checks. You can fail over an entire region if it's no longer valid. So even though you might get added latency because you're failing over to Europe or you're failing over to Singapore from Sydney or any of those kind of things, at least your application will be up. A bit of slowness is better than getting a 504 or like DNS timing out. So the other thing with Route 53 doing that, using that as a service is it's IAM integrated. So you can choose who gets to change that DNS. You can choose who gets to change health checks. We also have geo-blocking. So in CloudFront and Route 53, you can say, I do not want to serve DNS requests to this particular country block or this particular IP range or anything like that. So you can like granularly control where you serve content from which country, whether you block certain countries, whether you redirect certain countries to a sorry page to say that you don't accept something there. For instance, if you're like a financial services who doesn't have a license there, or a gambling company who's not allowed to take bets there, all that kind of stuff. We also have private DNS inside Route 53. So if you need to build just a private DNS and you want to do dev.local or something else, you can actually create a domain inside Route 53 and set it as private. And it will then attach to a VPC, and that VPC will now be dev.local. And we will manage that DNS for you, so you don't have to run bind servers or Active Directory servers, and it'll be all isolated into that private DNS. You can also do things like round robin and fallback. So if you have something like a splash page, you can set up a splash page in S3, and when your health checks fail, it can come over and say, sorry, we're down for site maintenance. You can fail back over to your on-premise solution. So if you have something in your VPC and it goes wrong because of an app deployment or some other thing, and the health checks fail, they will fail over to the same app that might be running on your on-premise if you need to stay up. So you can configure Route 53 a myriad of ways to basically move traffic around to where you want and only serve it to the places that you want. So CloudFront, like I said before, probably the most important feature of CloudFront, other than it being a geographically dispersed CDN, is that you can set the TTL at 0. You can proxy your dynamic content through CloudFront just like you can your static. It also has supported verbs just outside of the get verbs, so there's extended ones for option and other ones like that. You can also use private cookies and URL signing. So if you want to do something like lock CloudFront down so it can only hit your ELB and your VPC, you can do that. If you've got something like media where you don't want people to steal your content if they're going through the CDN, you can use things such as the private cookies or the URL stapling to basically lock CloudFront down so it can only request from your origin. So if someone does do a DNS lookup, gets your ELB public IPs and then tries to grab stuff without going through the CDN, we can block that. It is the edge for dropping bad requests and soaking up volumetric attacks. That is where you want it to happen. You do not want it to happen at your VPC. You don't want to have to scale to hundreds of instances to do that. We also have a private content option in CloudFront. So if you do need to serve out something to, say, people who have paid to get access to it or something like that, you can actually have private content serving, which you can then also on charge for if you want to. So if you need to do something that's not publicly accessible and you need to serve it out of a CDN, we do have options for that. CloudFront has full logging, so you can see who accessed what from where. It's integrated with CloudWatch metrics, so you can see how many requests per second you're getting, what countries are they served from, are they served from phone or tablet, all that kind of stuff. And you can use those to alarm on things like, all of a sudden I'm getting 50% of my traffic from the US, but I'm Australian. I'm an Australian company, so why is that happening? All those kind of things. So you can use that to shape how you receive traffic and how you send it back out. There's geo-blocking, so you can block particular sets of countries from not actually using the CDN. You can also do things like custom rules so that, for instance, you override the HTTP cache settings. So if you need to, for instance, make a dev change because now you need to make one of your images or some other story now at a 15-minute instead of a 30-minute request because of news or something like that, that's an event that's occurring, you can actually override that rule in CloudFront and say, when you see this piece of content or when you see start.jpg, now use this rule. So it's very configurable, and it's a good way for you to take load off your servers. Finally, so partner network. So we have the Amazon Marketplace. It is filled with hundreds and thousands of partner products that you can use. So there's WAFs in there, VPNs, IPSs, antivirus, deep inspection tools, data encryption, user management, a whole bunch of things that you can add on top of our AWS foundations to meet your security requirements. So if there's some service that's not quite doing it for you, you have some requirement that I haven't covered today, it is likely that there'll be some kind of partner tool through the marketplace or some kind of custom thing that you can do to be able to meet that security. You know, we've been talking about devices today such as FIPS2 compliant hardware, you know, PCI compliance, ISO 27001. These are all base things that we can achieve, and then you can achieve that with your content on top of. So definitely, if in the questions, if you feel like I haven't covered something, we've got guys online who are answering these kind of questions. Ask. I'm sure there's some solution that we can come up with that will meet your security requirements. So a lot of the stuff that I've talked about today is available at our Amazon-security site. Our compliance site lists all of those certifications and the audit programs that we currently have. We have risk and compliant CSA questionnaires, so if you need to get copies of our ISO certification, for instance, once you sign an NDA, you can request those from us. We also have Trusted Advisor, which we didn't talk about today, but that will show you security things like your ELBL is open to 000, or this security group is open to 000, which is on your web servers, those kind of things. And one last pitch for support, get support, even if you only buy developer support. Being able to raise tickets and talk to Amazon and us help you through your problems is what we're here for. Don't sit over there and read 20 blogs trying to figure something out if one of our support guys is going to be able to help you out with it much quicker. Okay, so that ends the talk. On Friday we're having Ask an Architect session, so it'll be one of my counterparts and you'll be able to sit there and through that session you'll be able to ask an architect anything that you would if that architect was on site at your client or was doing a site visit. So I strongly advise you, if you need access to that or you're thinking about designing and building something, go along to that architect session. It's on Friday, March 20th. Also, the last reminder is just around the survey. So there's a survey at the end of this talk. Let us know your feedback. Let us know how you'd like to tailor it for next time. Let us know if you if it hit the mark that you're talking about. And now, which I haven't written down because I wanted you to listen till the end, here's my 5 top tips for securing your AWS. First one is use an empty root account and use multiple accounts if you're an enterprise. If you're not an enterprise, then use multi-factor authentication, create roles, lock your users down, don't put credentials in our AMIs. Use edge services. Even if you're just going to proxy dynamic content through, use Route 53, use CloudFront, help yourself out. Use the edge services to offload bad packets and load off your servers. Don't expose your instances. There is generally no reason for you to give something an elastic IP. Put it behind a load balancer, put it behind a NAT server, route the internet traffic back through your direct connect or VPN into your own premise. There is no reason to be putting elastic IPs onto front-end boxes and exposing them to the internet. And the last one is there is no layer 2. So you don't need to worry about ARP poisoning. You don't need to worry about spam points. You can have a much flatter network in Amazon. We provide horizontal security through security groups. You can have 100 servers sitting in the same subnet which can't talk to each other. So design your networks that way. Don't go out and do, you know, a massive spider with a whole bunch of -27s everywhere with like 3 boxes in it and have all these different DMZs. Think about security a different way. We're trying to make it easier for you. We're giving you the tools to be able to separate those workloads so that you don't have to be a network engineer cutting up subnets to know that stuff. We also have online labs, instructor-led classes, and AWS certification. If you're an architect or you're into DevOps, we have architecture certifications, associate and professional, and we also have the new DevOps certification, go and get certified. If you want to work in AWS and you like working with the cloud, we have certifications online, we have test papers online. Go and learn more about it, go and get certified. You'll be glad that you did. Thank you for attending, and I'll hand back over to the presenter.